special guest, David Knickerbocker. Welcome to the show.
Hi, thanks everybody. Happy to be here.
Oh man, definitely glad to have you on. Yeah, we've been seeing that. You've been making some major strides. You recently released a book. Can you tell us a little bit about your book?
Yeah. Yeah, I got it right next to me actually. So I wrote this book, Network Science with Python. I wrote this because it's the coolest and most useful stuff that I've learned how to do in the last several years. I used to be a data operations engineer at McAfee and Intel, and I learned that this kind of network analysis can be very useful for things like mapping out data flow and stuff like that, more of the software type stuff and data type stuff. Um, but over time, I realized that this could also be extremely useful tied to natural language processing. And so you've got network science and natural language processing working together, whereas like the text is kind of the information that we share, and networks are the influence and the flow of how we actually share things. And so this book, I originally called it Network Thinking, but we had to come up with a simple title for people. But network thinking is really how I think about this book. The I used to do things with lists and Excel spreadsheets and stuff like that, but once the idea of graph and networks and just seeing that everywhere, once it takes root in how you think about things, you can't go backwards from that. So I wrote this book just off of um, kind of stuff that I've figured out over the last 6 or so years. I've been reading a ton of network science and social network analysis books, and the social sciences aren't always tied to software engineering, but I think that it can be. I think that there's usefulness when you do tie things together the way that I've done things. So that's what this book is about. It's an unusual Python book. Um, could be written in any language, really. Uh, Python was just the tool set that I think is most useful for doing this kind of stuff right now. But but yeah, the approaches that are in the book are they'll work in any language that has these capabilities. So that's kind of the background about what the book is. It goes very deep into it, not just creating a graph and visualizing a big spider web on a screen, but how to actually dig into the networks and interrogate the nodes and look at the ego networks and look at the connected components and stuff like that. And I use this stuff all the time. I use this today at work for about 5 hours. So
Oh
the
wow.
stuff I write about, I know it works because I use it at work all the time. And I just wanted to give that to the community and hope that other people will make use of it too.
Absolutely. So for like the average programmer, once they complete this book, what are some of the things it's going to allow them to do?
So I'm hoping that the first thing it does is it just makes people more aware of the networks that are all around us. And in the book, I use Alice in Wonderland, I use Animal Farm, but I also show how to use Twitter data and how to crawl the internet and stuff like that. And so, like my company, we crawl the entire internet. We've crawled billions of websites. And so my own data is just rich and really cool for doing this kind of analysis. But I want people to understand like that they can look at the relationships and they can like if you just do text aggregation, like just counting the number of times something happens, that can give you a little bit of insight, but it doesn't even scratch the surface for the depth of the insights that you can do if you actually construct a network and look at the page ranks, look at the communities and stuff like that. So to me, it caused kind of an explosion of thinking. Like I feel like the moment when I figured this stuff out was just kind of a life-changing moment for me. So really, I want like the biggest thing I want is network thinking, like just cause a shift, I guess, in how people think about things and give them the tools to actually dig into it.
So yeah, when was the moment that you actually everything started coming together?
It was at McAfee. I worked in the data operations team. Um, we were part of the labs group, so we got to do some really interesting stuff. And we had one problematic server that I was hired to uplift, and that's take it off of 15-year-old ancient hardware and put it on a brand new server. And the server had hundreds of scripts on it, and when I was hired, they told me I had like 20. And so I dissected the server and found out that it was much more complicated than originally told. And I was doing things with text files and just putting the scripts in a straight line and looking through them one at a time and trying to wrap my mind around things. And I did it. I did it without, I uplifted the server successfully without any network science whatsoever. Um, and I had to hold all of that in my head about how the server worked, how the data flows worked, and just hope that my documentation worked well enough. But after about 2 or 3 of these uplifts, I took a class on Coursera that introduced me to social network analysis. And I was actually kind of negative about that class because I don't want to analyze Facebook. Like, what is social network analysis? I thought this is a dumb course. I don't want to take it, but it was the last course in the series. And so I've already taken the other 4. I might as well take the 5th. And it introduced me to PageRank, and it introduced me to directed networks and stuff like that. And when I was at McAfee, malware is our bread and butter, and understanding how malware evolves, it evolves as a network. And I could see the data flowed in McAfee as a network, but I also understood that viruses evolve over time as well. And that made me start thinking ideas also evolve. Like this conversation that we're having right now, we're all going to leave this conversation and think about it, and we're going to reach different conclusions. Like we're gonna come away with different insights, even though it's the same stuff that we all talked about. Our own neural network took away something different and evolved it. And so there's this space and time happening between us. And so you can do temporal network analysis, time series network analysis. It's just, sorry if I sound like a mad scientist or anything. Like it's just crazy because you literally start connecting the dots, and that's what a network is. And so that moment happened to me at McAfee. Like I remember drawing on probably that whiteboard, some malware and how it could possibly evolve, and started writing my scribbles there at 1 a.m. about how I could maybe measure that over time. And so I started seeing that it was information, it was data flow, it was source code, it was the wildlife in my backyard. Like everything is networks. And it felt like we were very ill-equipped to actually study networks. And so I dove into network science head first, and social network analysis comes from the social sciences. So I dove into that head first too. And I brought them back to the computer science. So that's kind of the eureka moment for me.
Absolutely. Oh, did you want to say something, Sean?
Sorry. Who is the book geared towards? Like it's a topic I don't have any experience with. Is it the kind of book I would buy and read, or is it for somebody with a little more foundation?
No, it's actually, I tried to write it for non-coders, to be honest. It's got coding in it, but so when I was reading so much about social network analysis, one of the biggest complaints I would often see in these books, well, it's not a complaint. It would be like a statement, like, here's the analysis that we can do. And it would typically be a very small network, maybe a couple dozen nodes or something like that. And then it would have a sentence that if you had an engineer on your team, you could do much larger scale network analysis. And Alberto Barbassi, in his book on network science, he got his inspiration from web crawling. Like they were crawling the internet, trying to map all of that out. And it comes from social science and mathematics. And so I wrote this book, and I tried to write it in a way that my parents could read it easily. And they have a copy of this book, and they're not technical, they're not programmers. But I also work with some people in academia, and I wanted them to read this book. And so I just try to write as clearly as I can. It's not for programmers. I use programming as kind of my art. It's how I get stuff done. But anybody can read this book, I hope.
That's awesome.
Do you need to have any kind of mathematical background?
No. The chapters, so like one chapter will be on centralities, and there's a lot of math involved in that. But I link to the pages on NetworkX, on the NetworkX documentation, and the documentation itself links to the academic articles, so people can dive into them and read about the math to their heart's content. But I purposefully left it out of this. A lot of the data science books have these math formulas that are this long, and they're very intimidating. And when you're first getting started, you'll see those formulas. And I mean, my first machine learning book had that effect on me, to where the math freaked me out. And a coworker was just like, just you can learn that gradually. Just dive in and start getting familiar. And it doesn't mean that you can just ignore that stuff entirely, but you can learn that at your own pace. And so for me, I've been programming since I was 6 years old. Code is just natural to me. Like speaking is natural to me. And so that's just how I think. But you don't have to be a programmer. You don't have to be a great mathematician. Uh, Honestly, the code itself is pretty simple in the book. So I hope it will be approachable by everybody.
What kind of feedback have you been getting so far?
So the coolest one I got today was from a university professor who said that this book's perfect for something that he wants to teach. So uh, that's excellent to me. If a professor is using my book as source knowledge for their own in order to teach, then that's excellent. It doesn't get any better than that to me. But
That's like the pinnacle of accomplishment, isn't it?
yeah, that's really nice. Um, and people have asked me if I wanted to go teach, and I would like to do that someday, maybe when I get older. But I've got real problems that I want to solve right now, and not go teach yet. Like I'm actively building stuff right now. So to me, that makes me happy though, because academia is getting their hands on it and they're finding use for it. But also the OSINT community, open source intelligence community, is getting their hands on this book. And I work in OSINT, and this stuff is powerful for OSINT. And that makes me extremely happy to see them getting it, but not only getting it, actually using it and sharing screenshots with me that they've taken. Like, check this out. This is what I've done. This is the data source that I've used and stuff like that. So it's cool because, it's a bit of an academic subject, like if you read the social network analysis books, but I want to make this stuff practical. I don't want this to be just a theory book. I want you to take it and throw Alice in Wonderland at it if you like literature, or throw Russian propaganda at it if you work in national security, or throw some problematic text at it if you're going after problematic content, or, you can use this for all kinds of stuff. And I've used this even for malware detection when I worked at McAfee. So this stuff is truly useful in many different domains, and curiosity is really the limiting factor.
So, like for the average programmer, what are some of the problems they'll be able to solve, like once they really master the material in the book?
Probably the fun stuff is the fun stuff that won't ruin your mental health, I would say, is kind of the marketing stuff. Like if you dive into disinformation or propaganda or stuff like that, it gets really frustrating and kind of affects you negatively. So you have to have the fortitude to really do that kind of stuff. Otherwise, it does kind of mess you up. But it is also really a fun train wreck to go see sometimes too. So disinformation and propaganda is fun to analyze. But like, you could use this to in the book for my daughters. They're into K-pop, and so in this book I created a data feed of K-pop a couple years ago and crawled Twitter's K-pop ecosystem for a while, and that's in the book a little bit in the first chapters. And using things like PageRank and the different centralities, you can identify who are the most influential groups. And so one thing that I've liked to play with as a mental thing is, if I wanted to take like on LinkedIn, I have a very strong following. On Twitter, I'm non-existent. And so if I wanted to take my LinkedIn following and have success on Twitter, how would I do that? And one thing you could do, like if somebody wanted to become an influencer on a different platform, would be to study the ecosystem that they would like to plant themselves in, and see who the movers and the shakers are in that community. Who has the highest page rank? What are the different communities that exist in the ecosystem? Find your place to get planted in that ecosystem and start making friends. So like, networking has always been a part of business, but we've done it kind of blindly. We go to these networking events, we start shaking hands, and we hope that the person that we're shaking hands with is an actual useful person. but you could use this and open source intelligence to give yourself some really rich insights to who the really connected people are. And oftentimes it's not the famous people. It might just be the person who knows what they're talking about, and a lot of people use it as a source. So my recommendation to a beginner is just get creative. Like, think about something that you want to do. And in the book, I write some of these checklists. Like, when I talk about a new analysis, I'll say start with kind of the journalistic approach, like who, what, when, or why, how. So if a beginner wanted to study their favorite video game or how well it's doing on Twitter or something like that, who's talking about it? What are they saying? When are they saying it? How often are they saying it? Who is the most influential of the people that are talking about it? And so those page ranks and stuff like that. What are the sub communities that exist in the ecosystem? And that's community detection, which is like chapter 8 or something. If you want to do some predictive stuff, there's some cool machine learning at the back of the book. So it's really, first thing a programmer should do is just get creative. Like, read the first few chapters, just skim the whole book, like skim it, don't absorb everything, just skim the whole entire thing, kind of see what I'm doing and get creative, come up with some stuff. I write stuff on pieces of paper all the time, cross off the stuff that seems like a waste of time, and just go try to do one thing. And then at first it's going to be really difficult, and then after that it's tedious, and now I can do this stuff in my sleep. So it becomes super duper easy. So it's there's so many data science books on reading tabular data. This now gives people a way to work with really unstructured data, and pull graphs straight out of text. So
I know that you were talking about, like, your LinkedIn followers and everything. Some of the websites don't allow for web crawling, or they don't allow, their APIs to be open to everybody. So what can you do about it in that situation?
So I've crawled something like 2.6 billion domains and subdomains so far, and most of them are crawlable on the internet. Occasionally there's some media savvy, like the big websites will sometimes use JavaScript obfuscation in order to hide the content so that you can't crawl it so easily. I don't talk about it in the book because usually you don't need it, and it would have taken an additional 20 pages for me to talk about it. But you can tack Selenium onto your web scraping, and that will render the JavaScript into HTML, and then you can crawl it the rest of the way using requests or beautiful soup. I can't remember how exactly I did it. So nothing can really stop somebody who's persistent with crawling. You can always find a way. It's really if you want to spend the extra effort, or if you just want to dismiss that one problematic website and go get the other 99%. And I personally just go get the other 99% for now.
Do you know any like big companies that are doing it right now?
Big companies
That are doing like in the network science space. I know that you said malware and McAfee. Like, what other companies are using this?
So there are big companies that do crawling, and there are definitely companies that do network science. My own company does, but I can't talk too much about that right now. But we do very, very large scale network science for sure. And web crawling, there's a bunch of different companies that do web crawling, but they all do it differently, and it really depends on what they need. And in my opinion, every web crawling project is kind of different. So like, some people are going to want to just pull tabular data off of a website. So their crawling project might be to just pull data off of these 5 websites every now and then, and you don't need something large. But there are large scale companies that do crawling as well. I don't have their names off the top of my head, but I've looked them up. So
yeah, the idea that you gave, like, like finding the top influencers in a specific topic on LinkedIn, I mean, it seems like $1 billion idea if somebody is actually implementing this.
Yeah, I suspect that's why Microsoft bought LinkedIn, because now they have our data. Now they can see our networks. Like, that's to me, text data is just gold, and the internet is made of text data mostly, or I can't say mostly, I'm sorry, that's a dumb thing to say. The internet has a ton of untapped text data on a wide range of topics. And so when I learned how to do web crawling, and when I learned how to do, to use the Twitter API, it was like getting my hands on just a vault of gold ingots, like there's just rich content on any topic that I want to study, and I can find importance and stuff like that. LinkedIn, to me, I'll be honest, LinkedIn has been so problematic for crawling that I just gave up. But I know that other people do it. It's not worth it to me to do it. So I just don't. There's other ones that I go after. But yeah, I think that this stuff is I think this stuff is a many $billion idea for marketing, for national security, for I'm reading a book right now called The Ascent of Information, and it talks about how information is vital to our survival, and it's vital to the survival of all life. And so, if like these large generative models pollute the whole internet with so much text that we can't get to actual useful text anymore, what does that mean, for us in 20 years? So, yeah. Sorry, that took a dark turn, but these are the tools that you can use to prevent that apocalypse from happening.
So yeah, just to make it more tangible to the person who's not necessarily technologically savvy, like what are the primary tools you use and how do you use them in network analysis?
Yeah, so to me, natural language processing and network science are inseparable because they're just so incredibly useful together, because NLP has to do with the content and network science has to do with the relationships, and the importance of the thing that's sharing the content. So the two, to me, are inseparable, but they don't get taught that way. You can buy a book on NLP and it will just talk about classification, or it will talk about generative models, or it will talk about clustering, but it doesn't really bridge the gap into network science. And likewise, you can buy books on network science and they'll just be really math heavy, and they don't really bridge the gap, and bridging the gap is, I don't want to say pure gold, but bridging the gap, it's the insights are so informative to me. Like I'm doing some analysis right now, and I started the analysis by just doing some text aggregation, just some simple counts, like domain counts. What's the main domain that's talking about this, and that can tell you something. But what if nobody links to that domain? What if nobody visits that domain? Then it's just shouting to itself. It's putting out thousands of stories, but nobody links to it. Nobody reads it. It's not influential, right? But what if one website only put out 10 stories, but everybody links to it? And those 10 stories are extremely hateful or extremely damaging or extremely problematic in some way, then that's a domain worth paying attention to, or being aware that it exists, but good things are also the same way. Malware is a bad thing. Hate is a bad thing. Positive information is a very good thing. And so you can use these same kinds of network centralities and communities and stuff like that to identify the quality sources that exist, or to wipe out all of the noise and entirely and just get to the signal itself. So, wow, I think I totally probably didn't answer that question and spiraled a little bit there. Did I answer that okay, or did I leave anything off? Sorry.
Yeah, that was good, man. So is this pretty much the kind of technologies they use for like social networks to kind of like analyze the quality of a post and decide whether we need to promote this? Or
I think that with social networks, there's a lot of classification going on. And so like, if you want to see if something is positive or if something is very likely to give people a very happy user experience, like those are the kinds of things that LinkedIn definitely amplifies. And I like to play with their algorithm sometimes. Like yesterday when I made my post, I intentionally asked people to post memes, because memes make people laugh. Memes keep people happy. And so if you look in the thread, it's all people just having fun, and it's a book giveaway. And So LinkedIn, as far as I can tell, they don't really have strength. I better not talk smack about LinkedIn, but they seem to use these classification models. At least I can pick up on that. Like if you post something really positive, it will do really well. If you post something really positive and it has a picture, it does even better. If you post something really whiny, sometimes it will get stuck at 30 views and it will never go anywhere. It's like the model just suppresses it. And those models are pretty simple to create, just positive or negative. But personally, I like to create models that are a little bit more sensitive to emotions and things like that. It's like, this is happy, this is hateful, this is violent, this is et cetera, et cetera. And models can pick up on that kind of stuff too. And, it's possible that these social networks have these kinds of classifiers too, and they use that kind of stuff. Like if they had a hate classifier, they can push that stuff way down. If they have a sensitive material stuff, they can push that down. So, or if they have a positive classifier, they can push that stuff up. So these classifiers can be used for both different types of things. But also on social, a social network is a network. And so I don't know how exactly their network analysis stuff works or how well they do it, if they do it at all. I think mostly they're doing classification, but the networks, like, they help us. Like when I make my post, if 5 people with a lot of followers jump onto it and they start participating, then their network affects my post and so on. So it's harder to understand how that stuff happens if you don't know about networks or how they work. But once you start digging into this kind of stuff, it makes sense. Like, it's just, this is a ripple effect of multiple networks coming together. They're just converging.
So yeah, you kind of mentioned, you were able to detect emotion. How do you detect emotion? Like the words used, or?
Yeah, here's a cool book. I keep this one handy. This is the coolest cover ever. I love the cover on this book. It's my favorite book cover I've ever seen. It's just like the emotes on it. But on page 34, I've got it highlighted like crazy. It breaks emotions down into primary, secondary, and tertiary emotions. And I know you can't really read that very well, but I did some analysis at the very beginning of COVID about how different groups were talking about COVID and talking about vaccinations and things like that. And, there's nothing that will just automatically extract the emotions from a piece of text. But you can read something and you can tell if somebody's angry, and you can read something and tell if somebody is experiencing discomfort, like if this were a medical description or something like that. It's like, okay, clearly this person is describing discomfort. And so there are emotions that we can pick up, but there are other emotions that are much more tricky. And so I would say that the primary emotions are pretty easy to capture. Like, you can read something, you can say, yeah, this is humorous, this is angry, this is blah, 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 blah. And you can create your training data. Obviously, you're adding your own bias, and so you'd want to do that with a team of people to create a better data set. But you can build models that can pick up on certain emotions, and you can build models that can pick up on humor, and you can build models that can pick up on whatever it is that you want to pick up. It all comes down to the quality of the data set and how you build it and who works on it and the quality of the people that you work with and stuff like that.
So yeah, I know your software career kind of spans over 20 years. Can you give us a little bit about your background and what kind of led you down this path of network analysis?
Yeah, it's wild. I grew up on a tiny little tropical island in Japan. I moved to Okinawa, Japan when I was 6 years old, and I lived in Japan for 28 years. And so most of my adult life was actually in Japan. And as such, I don't really feel like I'm from anywhere because I didn't grow up in this country. I grew up outside of this country and as a foreigner. And so I lived over there in Japan, and there was a U.S. military. I mean, there is a big U.S. military presence on Okinawa, Japan. And so I worked teaching English to Japanese elementary schools for a few years, and that was great. teaching like 4th to 6th graders how to speak English. And that was at the very beginning of my career. I was doing freelance web development at the time, but teaching English paid a lot better than programming did for me at the time. And then a friend of mine started an ISP, little tiny internet company. And I met him outside of a convenience store, and he's like, "You should come work for me." And so I did. And so I quit my job teaching English, and I became their first programmer at that ISP. He was a Linux, I consider him a Linux god, and I knew my way around web development. And so we just started working together. But it was on a little tiny island. I didn't have anybody to ever go to for help. I had to go to Japanese bookstores, and a lot of my earliest programming books were in Japanese, and I couldn't read the text, but I could read the code, and I could kind of get a feel for what they're saying from the code, but none of the text made any sense to me. And so I still had to just kind of get a feel for it. So like my old HTML and CSS and PHP books were in Japanese. And having nobody to lean on means I had to become really scrappy, because it's just sink or swim. I remember when I was like 20 something and I blew up my first production database, there was nobody to help me clean that up. I had to do it by myself. And I had to apologize to all the customers because we were a small company, So eventually I got a job working with the US Navy at a military hospital in Okinawa, Japan, as a military contractor. And then when that dried up, I didn't want to start over on a little tiny tropical island. Like that contracting job paid a lot compared to the local salaries. And so I didn't want to go back to a tiny amount of money. I paid like 4 times more. So it was significant. And I decided I was doing really well in my career even back then, like 10 years ago. And so I thought, I want to go see what I can really do. And I moved to the West Coast. I didn't want to go to San Francisco because everybody goes to San Francisco. Everybody wanted to go to Silicon Valley. I wanted to go somewhere second or third place, that would have lots of jobs, but not as much demand. And so I moved to Seattle, and they still had a ton of demand, but I did manage to get jobs there. I got hired in Seattle. This is still kind of a funny and sore memory. I was a very senior person in Japan, but I got hired by a company in Seattle as a junior DBA, which I felt was a bit of a slap in the face, but I took it because I just needed to set an anchor in Seattle and move my family to the States. And so I took low pay, took the junior job, didn't expect to stay at that job for a long time because I knew that would be way too easy for me, but I just took it anyway. And then very quickly, I got pulled into another job as a senior DBA and senior security person, and then gradually moved to Portland, Oregon, where I worked for McAfee, the antivirus company. And then we got bought by Intel. And so I got to work in Intel. McAfee became Intel Security. So I got to work inside the actual Intel buildings, and I got tons of Intel t-shirts and my Intel hoodie. So I got so much swag from those days that I just love it. And I'm like walking distance from Intel at my house right now. So I love where I live. I guess the takeaway from that is like, I loved Portland because I loved the Portland area because it seemed like there was just as many jobs as Seattle had, but there was way less demand. And that kind of has to do with network effect too. Like if you think about Silicon Valley, Portland, and Seattle a little bit higher, Silicon Valley has just everybody. And so it's just this giant hub and you're competing with everybody. And Seattle is a hub, but it's not as much of one. And Portland is even less. But they had just as many jobs that I was seeing open. And Portland, no problem getting interviews for me whatsoever. Whereas Seattle is a lot more work. So network effect in action again. So that's kind of the history. And then a couple of years ago, I had a realization that cybersecurity is just not equipped to solve the problems that I want to go solve. They're related to cybersecurity. So kind of what I'm building in my company, it feels like the next generation of cybersecurity, but it also feels a little bit arrogant for me to say that, because, but it does. Like I'm filling holes that cybersecurity can't or won't fill, but I'm also bringing my cybersecurity knowledge to it. So I often joke that I'm building science fiction, sci-fi tech, I call it. But I want to take cybersecurity and I want to take it to the next level. So that's what my company does. And someday I'll be able to talk a little bit more openly about it.
Did you have any network analysis project where you were surprised by the results?
Every single time, I would say. The insights really come out. Really, it's wild because a network is never a single network, and like the one I was looking at today is actually the network is actually many different connected components. And one of the things that I talk about in the chapter of community detection is a first approach to community detection is to look at the connected components, because let's say we have this whole graph that's about this one topic. There's going to be all these different subgraphs in it, and they're all different sizes. And so a network has subnetworks, subgraphs, and each one of these has their own little tiny ecosystem. They're almost like a little tiny universe of their own, and each one of them has their own influencers, and each one of them has their own content types and stuff like that. So it's always a surprise, and it's like my favorite thing to do. Just throw on some trance music, blast through my headphones, and like just go loose on the data, because I'll look at all of the different, or I'll look at as many of the big connected components as I want. I'll do some NLP for similarity or to look for things that I'm looking for. But it's this NLP and it's this network science and social network analysis, the marriage between them, that makes it so powerful, I think. And all I can say is it's always a surprise, and it's always a pleasant thing to really dive into, because it's like a eureka moment every time you look at something. But that also tells me that it's just untapped value, it feels like, because it's so easy for me to find insights that are not common knowledge, that I want everybody to do this. Like, I don't want to be, I want everybody to do this and find their own.
No, I mean, do you ever get scared that like you don't know how much is out there? How much data is out there, and like
No.
people don't know any of these results. Like, I mean, you know it because you're doing it, but what about the rest of us? We don't know all this information.
It's anything can be learned if you try hard enough. Uh, my wife actually printed off one of my quotes and hung it up downstairs. But it came from one of my posts, and like I grew up just learning wherever I could. Like I said, I was learning from Japanese books, and I was learning from just whatever I could get. And so what I said back then was that whatever it is that you want to learn, if you try hard enough, you will. And it doesn't matter if you go to the library, or if you go to MIT. If you want to learn something badly enough, you will. And you just can't be afraid to learn. And you can't be, it's like jumping into the deep end. And so I understand that it's terrifying sometimes, and it feels like information overload. Like, where do you even start? This network stuff is too much. It's too big of a topic to really understand. But everything is just one step at a time. Like, how do you create a network edge list? That's the first thing you do, and a network edge list just has a source and a destination. So, okay, that's easy. How do I create a network edge list from a pandas data frame? Do I have two things that are related to each other? Great. Let's rename those columns as source and target. From that, you can create your network edge list. Okay, what's the next thing? How do I create a graph? I actually got stuck on that part for a long time. Like, great, I've got this data. How do I actually create a graph that I can work with? NetworkX has a cool function called, it's like NX from pandas edge list or something like that. And you just feed it a pandas data frame directly. When I saw that just accelerated everything, because I could go from pandas data frame to a graph and analyzing it in no time whatsoever. So you just kind of, what I do is just write a bunch of notes on a piece of paper and all the things that I want to do, and just attack them one by one. Like, software engineering is all about taking a big, complicated, intimidating problem and breaking it into smaller pieces, and then breaking those pieces into smaller pieces, and then attacking them one by one. And if you think about it, that is a network. Like, the network has the smaller pieces, and the smaller pieces have the smaller pieces. And so you're just attacking the outer edges of the network until you get to the whole thing as well. So you're attacking the many parts of a problem until you get the whole problem solved. In my experience, anything that I've wanted to learn, whether it be guitar or pottery or writing, it's just baby steps and committing yourself to actually doing it and then following through. So
I always tell people, if you have an imagination, if you think about it, man went to the moon from an imagination, and they just worked out the steps towards getting there. It's pretty much about consistency, really.
That's right.
Just keep going at it a little bit at a time.
That's right. It's really just, it seems so small that they're just little baby steps, and sometimes the baby steps feel really frustrating when you're in the moment, because it's like, this will never take us anywhere, but it does. And David had a question: how often does it feel like a story unfolding as you learn new insights from the data? That's actually what I'm working on today, is telling a story with some data. And there is always a story in there, and the nodes will tell you the story, and the communities will tell you the story. The direction of the edges will tell you the story. And it's always a very interesting story. And I feel like the analysis that I am doing today for work, I could turn that into a 100-page book if I wanted to. The raw data for that, the raw data for this analysis would probably fill 300 pages in a Google document if I just dumped it. And so there is a story in any kind of network analysis that I do, especially when tied to NLP, because there's both sides to that story. But the storytelling comes naturally because the two sides connect. So I hope that answered David's question. There is always a story in there, though.
So yeah, we often hear a lot about like the interview process, like the lead code grind, data structures and algorithms. Which out of all of that stuff do you find like practical and applicable on the actual job? Like which data structures, which algorithms versus the impractical?
So to me, the way that I nail interviews isn't from memorization, and it's not from memorizing algorithms or how they work. It's really about my storytelling as a software developer. And I've been offered jobs by the CTO of companies after a single interview because I go, and he wasn't the person interviewing me. I was interviewed by a manager who liked me so much that he brought me to the CTO to talk to, who offered me the job that day. And even that day offered to pay for my PhD and all kinds of other stuff. And I didn't take that. I didn't end up taking it. But like the way that I get those the way that I was getting those kinds of offers, it's not memorization. In fact, when people talk tech trivia to me on interviews, I try to move the conversation away because I hate talking tech trivia, like algorithms and sorting. And I just call it tech trivia. Like, I'm really dismissive of it. I like to talk ideas and how I solve them. Or things that I built and how I went about doing it. And those kinds of stories are very easy to tell. And so, like the question or the thing that I brought up earlier, this one problematic server that McAfee hired me to uplift, this server was causing many people pain in the company, and it's a very critical server. And every company has critical servers. Every company has pain points. And so for me to say, this is how I dissected it, I didn't have to say these are the algorithms. I didn't have to say I used an Excel spreadsheet here. I used a text file here. I just said, this is the approach. Map out the source code, work your way backwards, analyze the data flows, make sure that it works when you're going backwards to front. If you do it that way, by the time you go forwards to backwards, the data flow works. I know that probably doesn't make a lot of sense, but like that's my approach to doing source code analysis. And that approach led me to 20 successful uplifts with 0 failures whatsoever and 0 issues during any uplifts. And it's very easy for me to tell that story. And everybody has problematic servers and everybody has problematic workflows. And so for me, when I tell that kind of story, it really resonates because they want to get their problem solved. They don't care how I solve it, So I kind of hate those kinds of interview type things, like learn these algorithms, blah, 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 because they're not really differentiators to begin with. They're just stuff that everybody learns. And you do need to know them. Like, you have to have a strong foundation in order to be successful, but you should have that strong foundation anyway. You should go get it. Like, you should go figure out what the best practices are. You should always be learning, always be reading. But like, I shouldn't have to describe that in an interview. I'd rather talk about how I solve problems. So like, I've actually failed interviews badly because I refused to interview. I refused to talk tech trivia. Like, it was a Spark interview and they wanted to go into Hive internals. And I said, nobody, like, I don't want to talk about Hive. And they didn't like that. And they kept like, well, we need to talk about it. And I was like, no, I'm not going to talk about this. Let's talk about what kinds of data flows are important to you. You know, let's talk about the kind of work that I will be doing. Like, what kind of problems will I be solving? What does your company do? Do you make slot machine video game apps? Like, do you do medical stuff that's going to save lives? Like, let's talk about that, and let me tell you about how I do stuff. So, but for a beginner, to ace interviews, always be learning and always be building. Like, you can't count on an employer to train you. To say that, employers should offer training, and the best ones offer tuition assistance and offer training and reimburse you for books and stuff like that. Oh, but take care. But you have to always be learning. You have to always be reading, and companies will give you some training and some resources and stuff like that, but they're usually the resources for the things that they want you to learn. Like, one company wanted me to go be DevOps. I didn't want to go be DevOps. I wanted to go learn data science, and so I did. If I only followed what companies wanted me to learn, I wouldn't be doing what I'm doing right now. I wouldn't have my own company right now if I followed what my managers want me to do. You have to be independent. You have to go learn what you want to learn, and you have to be persistent about it, and you can't let anybody stop you, including your own manager. You just have to just do what you want to do. If you can't learn that stuff on the job, you have to learn it outside the job. It's your brain. Like, yeah.
If you have like a manager that's kind of trying to push you down the path you don't want to go down, how do you approach like saying, no, I don't really want to do that?
Well, you got to keep them happy. But in my experience, those managers are never your managers forever. And eventually they go away. Or eventually you go find a new team to work on. So you have to always be learning the stuff that interests you and thinking about what the next step is. But you also have to keep that manager happy. So, you know, I did go study some DevOps. I do have some DevOps books behind me on this bookshelf. I actually do love things like infrastructure as code. Like, when I was reading that book back in like 2017 or whatever, that was fascinating to me. And now everything is infrastructure as code and endpoints and stuff like that. So it is good to learn DevOps. Everything that you learn is going to be valuable. And I was on a data operations team, so it was very valuable for me to know that kind of stuff. But you also have to keep yourself mentally happy and curious and creative. And so that means that you have to be studying the stuff that you want to learn. So I am always reading books, including stuff that is outside of my domain, just because I learn the most useful stuff from the adjacent sciences, I often say. I feel like I missed a question. Did I miss one, or did you?
David says, what does a company do? What problem needs to be solved? I can definitely understand that. The technical details can be fun, but at the end of the day, it's the problem being solved that's important.
That's right. Yep. That's to me the yes or no for whether I'm going to take a job or not. Like, to me, I made a commitment to myself a couple of years ago that I would only use data science to benefit society, to benefit humans. I'm not using it to make people profitable. Like, I don't want to just make people's investments better. I don't care about that kind of stuff at all. So the problems that I go after are kind of, one, I like to solve the problems that nobody's even looking at. Maybe they don't know how to solve it. And so, like, that's where this NLP and network stuff is very, very useful, because this isn't common knowledge. And that's one of the reasons I want to make it common knowledge, is so that other people can go solve these things too. But yeah, like, I accepted the job at the military hospital because I wanted my database skills to go help save lives. And I worked for McAfee because I wanted to make the internet a little bit safer, you know. And I created my own company because I wanted to make it a little bit safer beyond what I feel that cybersecurity can currently do. I'm going to take my swing at make it even better. So, yep.
So yeah, like things are progressing really quickly in society. A lot of change. Technology is having a huge effect on everything. Like where do you see like the future going in the next 5 to 10 years? What are the major technological trends that are going to dominate? I know like AI is a big one.
Yeah. I think that I'm really happy to see that these language models are becoming popular, but I'm also a little bit terrified of them, um, because I can already see them being used in the wild right now. But it seems like earlier models being used, like most of the internet is made of junk, that is not for humans, and it looks like generative models just populate that stuff. So just generative models just dumping content all over the internet and gets ad money and keeps those websites paid and blah 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 blah. So what happens if these giant models make it even easier to do that kind of stuff? And what happens if instead of 1% of the internet being content, it becomes 0.0000001% of the internet is content, and even Google can't work anymore because there's so much crap on the internet that we can't find the signal. Everything is noise, you know. So these generative models kind of freak me out a little bit because they can be used maliciously. um, you could use them to make phishing attacks, read like plain English. you know you could use them to just pollute the whole internet and make it unusable. um, Honestly, I know that they can be used for really creative purposes, and they can be big time savers, and I've been talking about that for a couple years too. Like I made a Christmas poem generator, and I think it's really cute. And I like creating generative models that are smaller and single purpose like that. But the bigger ones, I'm more afraid of them than I feel that they're useful. But also I have some security paranoia too. That is just a permanent part of me from working in security for so long. Um, that I'm always a little bit suspicious of things at first. So I can't help it. It's one of my biases, I guess. Um, but that's getting people excited about natural language processing. And to me, the biggest thing that people can learn is really natural language processing, because the internet is text that can be used with natural language processing. And if you can learn it, then that's yours to play with. It's an unlimited playground for you to learn whatever it is that you want to learn and build whatever products that you want to build. And it's not that much of a learning curve. And what's in chapter like 3 or 4 of my book could get you started. So I think NLP is going to be huge. Um, I hope that this network stuff becomes huge, but I kind of expect it to always be the dark arts that it's ninja skills, and it will never be as popular as machine learning. But to me, it's more useful than machine learning. I use this stuff much more often than I use machine learning. So it's hard to say where trends will go, because trends and trends aren't really a thing to base too much off of either, because trends just mean a lot of people are following it, not that it's useful. And so right now, like Chat GPT is the trend, and there's so much noise about Chat GPT, but it's not mostly useful, you know. Whereas somebody made a post yesterday about a new kind of paint that doesn't lose its color even after thousands of years, and that to me is breathtaking. Like, that's incredible, and nobody talks about it. And that's far more long-reaching than Chat GPT is to me, because like, what happens if our paintings can last for hundreds of thousands of years? What kind of legacy can we leave to future generations and stuff like that? So yeah, data science is a hot trend, but I do encourage people to learn this network science stuff, because it's just a superpower. Um, but it might never become popular. But I'm pleased to see, like, the book was the #1 bestseller for new release for Python programming for a few days last week. So it's getting some traction. That's kind of cool.
I have a question on this. So let's just say I go into Google and I search, right? And it shows some results, but it doesn't show the result that I want. It shows the result that the SEO, the
Yep.
number thing want. I was like, can this network, like these generative models, has help us, remove these searches?
Yeah, I have a few problems with Google. One of them is that their top ads are their sponsored ads these days. When
Yeah,
Google
yeah.
was built, it was built around PageRank in order to identify what the most important domains were. And so that's the honest approach. Like this domain sits between all these other domains and gets linked to, so it's the resource that everybody should link to. But bad domains do that too. Hateful domains do that too, where they all link to each other. So PageRank can show you the worst of the worst or the best of the best. And I think Google didn't like that, and so they just I'm speculating, but I think Google didn't like that, and so they show sponsored ads because it's a little bit safer and less likely to give people malware, and they really are careful with what their top results are and stuff like that. I don't. I wouldn't say that generative models are going to be more useful for cutting through the noise, because generative models, they really just predict the next word, and people use words like they hallucinate and stuff like that, but they really just predict the next word that goes after it. And if it's something that a lot of people are talking about, then that's going to have different results than if it's something that very few people are talking about on the predictability of the next word and stuff like that. So I wouldn't use a generative model for search personally. And I know that that's how ChatGPT is kind of being used right now. And I've been pushing against that since the very beginning, because a generative model is just not a search engine. Networks have more to do with search engines than generative models do. But NLP can be very useful. Like you could use the Google app to do some searches, to download the Google Python library to do some searches, to pull a bunch of data. And then you could do things like clustering if you wanted to just wipe out a bunch of noise. So NLP, I would say, is the thing that's going to get you more value than any of these chatbots or anything. Oh, in regard to generative. How do I feel about deepfakes? That is a good question. Yep. Are we still okay on time? Are you guys okay for me to answer this one?
Yeah, sure.
Okay, I'm not in a rush or anything. Deepfakes are actually why I got into natural language processing, to be blunt. Deepfakes were the thing that I felt not afraid of, but I felt were going to be a really big thing that could be useful to start a war, for instance.
Yep.
So, and at the time, McAfee was interested in that too. And so I started hanging out with a data scientist who was doing some deepfake work. And I just started helping her with everything I could. And at the time, she was much better at machine learning, and I didn't know very much, or I didn't know nearly as well as I do now. And so I was doing more of just helping her with some stuff. And so she would do more with like deep learning kind of stuff, like trying to see lip movements or eyeballs and detecting a fake person and stuff like that. And I was getting into natural language processing, and so building my first classifiers. And so I was building a classifier I built a classifier back then that could detect human versus AI text with pretty high accuracy. And then I just kept going down that rabbit hole. But yeah, deep fakes to me are the whole reason why I got into this. And they eventually led me to now having my own company and writing this book. So deep fakes are crucial to my evolution into getting into this kind of stuff. I do think that the tools that exist now can make deep fakes much more easily. But I don't hear people talk about deep fakes anymore. Like they just don't call it deep fakes anymore. They talk about, look at this cool picture that was made using this model. They don't call them deep fakes, but they're deep fakes. They're just not being used to mimic an actual person, except for the profile picture ones that are all artsy and stuff. But
Do
yeah,
you
I
work?
think,
Oh,
go ahead.
go ahead. I was just saying, do you wonder, do you worry about like humanity kind of dumbing itself down as we continually rely more on AI to produce articles, and it's kind of like a self-fulfilling cycle. If we're not producing new content, then the AI is analyzing almost itself, like it's no longer analyzing.
I think that right now we are at the mercy of bad people who understand network science and understand network influence. Because if you can divide a population, then you can more easily attack a population or control a population. And so, like our own ecosystem is very divided, to the point where people can't even be friendly sometimes. And so there's the dumbing down part, but I think that the dumbing down part can be intentional. And I think that the divisiveness part can be intentional. And that's some of the stuff that I do for work, is understanding influence and understanding flow and understanding how ideas get moved and evolve, and where they start and stuff like that. And because, like, who needs to shoot bullets when you can convince people to not get vaccinated, for instance, or stuff like that, you know? And that becomes even a divisive thing to talk about, you know, like that's how influenced we are. So dumbing down, I'm less afraid of, because we are being influenced right now, and I can see it easily because I know how to do this kind of stuff. That to me is more of a threat than the dumbing down part. Um, but regarding the dumbing down part, that kind of gets back to what I was saying about how these generative models could just create a bunch of crap text on the internet and take our signal from 0.01 to 0.00001, you know, to where search engines don't even work anymore. What happens if we can't get information that we need anymore? Like, what's that going to do to us? And that's similar to dumbing down, but it's more like, if you starve the brain of oxygen, we're going to die. You know, if you starve the brain of blood, we're going to die. What happens if you starve a whole community, a whole country of quality information? Like, what kind of catastrophic impact would this have? And this is the kind of, like, I want to write science fiction someday. These are the things that I'll probably write about, but it's pretty terrifying to think about.
I know, like with AI, as it becomes increasingly more powerful, I believe it can also create like a social divide, like the people who have access to the really powerful AIs versus the people who don't.
Mm-hmm.
Like, you know, if they have access to this AI that's way more advanced than any human is, then they are essentially in control of society in a way.
Yeah, there's part of that. And I kind of think that those large language models kind of want to be that, you know, but not everybody needs those. Like, you can build a classifier in hours, and it might not be very good, but you can build a classifier in hours, you know, and you can spend days and make it better. You could spend a month and make it really good. You could deploy it on something and put it behind an API and give it to the world. So, like, I could build a very solid model and put it behind an API and just help people if that's what was needed, you know, like, um, writing books like this that share this kind of skill opens up this knowledge to everybody. Like, there's all of this is open source. There's no reason to have to become so reliant on these massive companies that don't have anyone's best interests at heart. Yeah, libraries are, I mean, abstraction is always going to be important. Like, abstraction makes things easier, makes it possible to solve more complicated problems. If you have to write 300 lines to read a CSV file, then you're not writing 299 lines to go do something else more valuable with that CSV data.
I
So,
think I think he meant like actual libraries, like
oh,
like a physical library.
yeah. Well, then both. Yeah, that at that time, then physical libraries will become important again.
It's scary that like we talk about the positive impact of having this network science, but I also like more than positive, the negative impact is much worse. Like finding the right group of people and giving them the right information or the wrong information for that point will just
Mhm.
like ruin it. As you said, like it may ruin a country because they
That's
can
right.
pinpoint the people that can do that.
So there is a saying in cybersecurity that defenders think in lists and attackers think in graphs. Um, Attackers think in networks. And so and actually in my book, there's one section where I destroy the Alice in Wonderland network. Like, for fun, I say, let's pretend that the Queen of Hearts wins for once. What happens if she takes out Alice, the Mad Hatter, the White Rabbit, and March Hare? And the network shatters. Like, this whole connected network just shatters like the Death Star at the end of Star Wars, because in order to disrupt the network, you only have to take out a few key nodes. And if you understand network science and centralities, you can identify those key nodes. And if you take out those key nodes, then the whole ecosystem collapses. It just shatters. So you can use it for offense or defense. Like if you understand your own ecosystem, you can bolster your own network. Like if you understand your own infrastructure, you can build resiliency here, so that you can safeguard against attacks. If you understand your information ecosystem, you can spot weaknesses, or you can spot where influence is happening. If you know where hate's coming from, you can spot that and you can do something about it. So understand, like, it's not one or the other. It's not better for the attacker or better for the defender. It's truly better for both. And right now, I feel that the attackers know this and the defenders don't, because that's been a saying in security for a while, that attackers think in graphs.
So what do you think about like companies introducing their biases into these AIs? If they have a political bias, they're slanting it, and everybody's dependent on these things for information. But it's kind of really controlling the population if they can only get access to a limited subset of information.
Yeah, it's a tricky one, because no matter what, with natural language processing, people are going to be involved in building the training data. And somebody's going to say this should be included and this should not be included. This deserves a label of 1 and this doesn't deserve a label of 1. And so when you work with, if it's just one person creating the training data, then bias can easily get in. If you have 10 people working on it, if you have 3 people on it, then you can have a vote, whether this belongs, whether it doesn't belong. If you have 10 people working on it, then it's even better. And if you, for instance, were to build some kind of community feedback way, then it can be even better, because then it's learning off of many, many more people, and it's less susceptible to attack, poisoning the training data and stuff like that. So with natural language processing, in data science, they always say to remove the bias, to make the pure data sets that are needed for machine learning and blah, blah, blah. But with natural language processing, everybody is just doing their best, in my opinion. And you'll know very quickly if the model doesn't work off of good data. And if it's not usable for your customers, they'll tell you very quickly and stuff like that. But everybody does build their own models. Like LinkedIn has their own data science team, and those teams have managers, and those managers probably dictate as much bias as the people who are creating the training data themselves. So
How can like a normal person protect against all this? Like if you're a programmer, yes, like it may take you some time. You can create your own models. You'll know what the biases are. But what if there's a normal person on LinkedIn, doing his thing? How can he protect himself from this, either positive or negativity, I guess?
we're kind of at the mercy of the data science teams of whatever platform that we use, and that's unfortunate. And LinkedIn, I've actually blocked their trust and safety team, because they're unhelpful, and I got tired of reaching out to them. And so instead of being frustrated, I just blocked their whole team, so I'd stop sending them reports, because they're not going to do anything about it. And so they have their own bias. They're very loose about what they allow. They allow a lot of bad things on LinkedIn, but because most people are pretty tame on LinkedIn, we don't see it very often. You have to go look for it on LinkedIn to find it. Whereas other social networks, they all have their own different data science teams, and their models are going to behave differently as well. My favorite game to play with LinkedIn is I like to toy with their models. So like if I have something that needs to be said and is a very serious thing, I'll play with their sentiment models and I'll post it in a joking way, and I'll put a bunch of LOLs and just make it into a fun post, but it will not be a fun post, And so if I can't beat them, then I'm going to at least have fun with their models, because the only other alternative is to just quit their platform. So,
Sure.
So yeah, it seems like you have a pretty big following on LinkedIn. Has that following like made any interesting opportunities available to you?
yeah. And yeah, the following is pretty incredible. I never expected it to happen, and it just happened because I was thinking about that yesterday. I was reading a book called The Code Book, which was about encryption, the history of encryption back in like 2017. And I was just sharing some of the stuff that I was learning from history of encryption, and me and my daughter were making our own encryption algorithms. And I challenged people on LinkedIn to break our encryption, and I'd buy them a copy of the book if they did. And so people tried and they couldn't beat it. So I think I bought maybe one person a book just to do it as a giveaway or something. But like I had like 500 followers back then, and I was just having fun, and I just wanted LinkedIn to be fun. And now it's like 31,000 or 32,000 or something like that. And my wife likes checking it more than I do. Like I don't care. I just like sharing what I learn. But it has gotten me opportunities. Like a couple of years ago, I helped with some data analysis that got presented at DEF CON, which is one of the biggest security conferences in the world. And this book came from me having a LinkedIn following and people being aware that I write about this stuff. I was asked to write a book. I have a company now because of people I know on LinkedIn. So literally, I was able to quit my job at McAfee and create a company because of having a following. And that's not to say that everybody go out and go become influencers. Like my daughter wants to go become a YouTuber. And I'll ask her, what are you going to make YouTube videos about? And she wants to make YouTube videos about video gaming. So it's like, cool, you're sharing information. This is going to help somebody. Go do that. That's an excellent thing to do. But there are other influencers that just seem to be about following. And if there's no content behind that following, it's just dead noise to me. It doesn't mean anything. It's just great. You've been successful on a platform, and but yeah, my following it's just given me so many opportunities. Like I got a company. We're able to go attack really difficult problems that nobody else has really solved yet, and we're doing really well on it. I was in a research paper about Russian propaganda this year that was shared around quite a bit in national security circles, and so that was very cool. And all of this just comes from sharing information. Like all of this just comes from reading the code book and sharing my knowledge. So I don't feel like an expert at anything. I just like to read stuff. And so like right now I'm reading about Julia, and I'm telling you guys what I learned about Julia. Like I'm definitely not an expert at Julia. I know it well enough to make a data frame and create a network, but that's more than somebody who hasn't done that yet knows. So if I share it, then that saves somebody else time.
So like, do you have any general career advice for like newer programmers and people really looking to further their career?
Yeah. All right. You have to listen to your manager. You have to be polite to your manager because they pay you. But you don't have to listen to them about everything. Like you need to study the stuff that you want to study. Like a job is just a job. A career and a job is different. To me, a career, like I have a career in making the world safer. That's my career. I have a career in protecting information because it protects people. Everything I do is about helping people and about protecting people. And so that's why I work in cybersecurity. That's why I work in what I do now. So my career is that. My job was McAfee. My job was Intel. My job was Nuance and the Navy hospital and stuff like that. Those are jobs. You need to think about your career. You need to think about what is your one anchor. What's the one thing that you want to do? Like, is it to help people? Is it to go be rich? And there are people who want to just go be rich so that they can travel and do stuff. Like if that's the thing you need to do to go do that, figure out how to do that thing and go make your career over that. Like go figure out how to make $500,000 quickly if that's the thing that you want to do. For me, money is not my priority, and money follows you as you get better at what you do. And so I make good money, but money is not my priority. I can go make more money if I wanted to. I don't want to. Like I'm happy with what I have right now because I want to build this great thing that I'm building. So my advice is to find your career, find the thing that you want to do, then find jobs that map to that career. And when you work in those jobs, you're going to have managers, and some of them suck, and some of them are great. Learn from the ones that are great. Learn from the ones that suck. Learn the things that you don't like about that. Like learn how to become a humane person. Learn how to support your teammates when you have a toxic boss. learn how to protect your teammates, learn how to defend, learn how to defend their ideas. Like in the worst times, you learn so much from the worst crap, but you also learn so much from the good stuff. Like I had a manager named Bob who to this day I just think so positively about, and he was a very short time manager of mine, but I learned so much about empathy, and I learned so much about taking care of my team and just being a good human being from this person. And I was a bit arrogant before I worked with him, and that went away after working with him. So find your leaders. Toxic personalities, those are not your leaders. People that are trying to solve problems, people that are trying to help people, those are your leaders. Like rally around them, help them solve their problems. I could ramble on about this stuff all day, but learn the stuff that keeps you going, because you are going to have hard times, and it's your curiosities that you can fall back on. Even if you're having a bad day at work, you can open up a CSV file and do 30 minutes of data analysis and restore your balance and and get back to work on the more problematic stuff. So yeah, I could do this all day. Sorry.
Yeah, we definitely have to save that for like a second show.
Yeah, anytime.
What about you, Roger? Do you have any more questions?
No.
So where can everybody find you at?
You can always find me on LinkedIn, and if you guys hit a snag with the book, let me know. Because if anybody's finding a snag, then more than one person's finding a snag. Like Python libraries evolve, eventually things stop working. So tell me if you hit a snag. I'll write about it on Medium so that nobody else has that problem or something. Let's keep this book evolving and helping people. And but yeah, I'm a friendly guy. You can message me on LinkedIn. I've made a lot of friends there. I don't really do other social media. Everything else is just for friends.
And
But
where can people get your book at?
you can get it on Amazon. Just search for Network Science with Python. They gave it a cool custom cover. Most packed books are black, so they gave it a really custom cover, which is really cool. And a really nice thing about it is that they printed the pages in full color, which I've never seen Pack do before. But in a network book, that's really nice because networks are a bunch of dots with lines. So being able to see the red dot versus the yellow dot is useful sometimes. So yeah, but you can get on Amazon. Yep.
Yeah, man. Well, we definitely appreciate you for stopping by, man. We definitely have to have you again.
Thank you, man. I had a really great time.
Oh
This
yeah,
was a good
so did
ending to
we,
my
man.
day.
We learned a ton.
Awesome. Happy to do it anytime.
All right, thank you everybody for tuning in. We'll catch y'all next time.